call the field causal inference. So what does this mean? We kind of so inference, right, is kind of the basic task of statistics, right? So inference is kind of using data to understand something that we can't be 100% certain of, right? So causal inference is kind of using data to infer causality and estimate not only is there a causal effect, but how big is the causal effect? How does it? How does one variable impact the other? If I manipulate the cause, how will the effect? How will the effect behave? So this is very close to traditional statistics. Causal inference just comes and says, well, when we have a certain set of assumptions, the thing you were doing with statistics for the past 100 years, well, it can be interpreted as causality in specific cases. So that's like the basic. And then causal discovery, it kind of takes the other approach. Causal discovery is about, okay, look, I have this huge amount of data that is maybe from a complex system. Like, I don't know, we have this huge hospital database with thousands of variables and millions or hundreds of thousands of patients. Or we have this complex manufacturer that has a bunch of sensors everywhere that measure in real time thousands of variables. And we kind of want to ask, okay, is there some cause and effect relationships that I can kind of discover in this data? And that is causal discovery. So you start from the data and you try to find a causal model. Whereas in causal inference and in statistical inference in general, you make a statistical model, right? You might make it a causal statistical model, and then you look, does the data fit this model? But causal discovery is you look at the data and you try to find a model that fits. So it's like two different approaches,